Hey, what's up YouTube? This is GHS InfoSec. Welcome back to another video. And in this video, we're going to be looking at one of the challenges from the Cyber Apocalypse 2022 Intergalactic Chase. This is the after event. I tried going through and actually recording my screen while I walked through this challenge and just had some difficulty with that. So I'm going to just narrate the part of reading the challenge description. This is a forensics challenge. It's called automation, and then I'm going to actually walk through and demonstrate how I solved it, since I can no longer access the description for this challenge. So it says here that Veneer's threat intelligence is monitoring closely all APT groups from every possible galaxy, especially the most dangerous one along here. As stated by an anonymous threat intelligence officer, the malicious actors tend to automate their initial post-exploitation enumeration so they can have less on-keyboard time. You can find such an example in the provided network capture generated by a recent incident. Analyze it and find out what they're up to. So this challenge does have a downloadable part, and so we're going to download that. I've already got it downloaded and extracted, and we're going to take a look at it. All right, so we're over here in the terminal, and if we take a look at the files that we're given this forensicsautomation.zip file, and if we unzip that, we end up getting this capture.pcap. And so if we take a look with the command line tool capinfos on capture.pcap, it'll give us a little bit of information about this capture file. And it has 4,809 packets, and the capture duration was about 46 seconds, which is fairly useful for us to know. So we can go ahead and open this up in Wireshark and take a look at it a little bit further. And we just see, lots of TCP, TLS traffic. We have some HTTP traffic. It's not decoded as HTTP, but we know that it's coming from port 80 to some ephemeral port. So this is most likely some kind of HTTP traffic. And Wireshark usually colors those in this green color by default. We have a little bit of DNS traffic in there as well. And we're just going to scroll through quickly. We can see some more DNS packets. And so we can take a look at the statistics for this by going up and clicking statistics and looking at the protocol hierarchy to get an idea of what protocols were discovered in this capture. And we see some IPv4 UDP traffic, which makes up about 3.6%. DNS traffic makes up about 3.5% of that with 168 packets. That seems like a lot of DNS, so we're going to take a look at that. And then we have some HTTP with some media and whatnot. And one other thing I always like to look at is the conversations, because it shows you the addresses that we're communicating in this capture. We have one address that's communicating with a lot of different other addresses. So we're going to go ahead and see if we can get a quick win with the exporting HTTP objects. And we can see that we've got quite a bit of stuff here to look at. So the first thing that really kind of caught my eyes, there's a lot of executables, and these appear to be Windows updates. But then there's also this windowsliveupdater.com, and it has an image file, a PNG, or desktop.png. And when I click on that, you can see it jumps to that packet in the frames back here. So we'll take a look at that in a second. But I've never encountered this as a legitimate Windows update domain, and the fact that it's getting an image rather than an executable or an MSI file seems a little bit odd. So we can actually save this file, and we'll just call it desktop.png. That's fine. We'll save it, and we'll close this. And if we right click on this packet that we got, right off the bat, you can see the data that's encoded in this packet in the packet details. So if we take a look at it, right click, follow the TCP stream, we see that it's a GET request to desktop.png for the host windowsliveupdater.com, and then we get a 200 OK, meaning it was successful. And then we get this, instead of getting the typical PNG magic bytes or file header, we get this really huge section of data, and it looks to be base 64, which is, number one, the format's kind of a dead giveaway, but also the equal sign, which is like padding for base 64, is also a giveaway that this is some kind of base 64 encoded something. So I thought that was interesting. So we've already actually saved the file, so we don't need to copy this down. So I'm going to go back over to the terminal, and we can actually go ahead and we'll kill our Wireshark for now, and we'll bring it back up in a minute. So if we take a look at this desktop.png, and let's say we run file on desktop.png, we see that it's ASCII text with very long lines. So this is not actually an image file. So if we ran this with maybe cat, if we cat desktop.png, we see that we get our base64 encoded string. Ordinarily, if you were to try to cat an image file, it wouldn't let you do that. So I'm going to go to the top here. Actually, since we can cat this out, we can cat desktop.png, and then we can pipe it into base64, tag D, and you can see by my suggested completions for ZSH that I've already, figured this out. Again, this is after the competition. I've gone this far. So we can see that this actually is a PowerShell script. So it looks like it's creating an AES manage object. So it's going to be some type of encrypted string, and then it's going to return some AES managed data. It's going to create the key. We have another function to encrypt a string, and we have a function to decrypt a string. And then we have these DNS queries with things like resolve-DNS name, type text, DNS only, Windows Live Updater.com. It gives us our server, and we're getting the strings for that, doing some other operations on it. And we're going to see in our packet capture that we get something.windowsliveupdater.com. So that's something that we're going to be interested in a little bit. But I'm going to go ahead and just redirect this into script.ps1. And just to make sure that we got everything that we need here, it didn't miss any characters. It looks like we got all of the characters that we need. So that's cool. So I'm going to go ahead and quit out of this. And since we know we're looking for some DNS traffic in our Wireshark capture, we're going to go ahead and open our capture back up in Wireshark. We'll do a filter for DNS, and we can see we have some upper and lowercase DNS queries for various Microsoft domains, which is a little odd. But then we have the text query for the windowsliveupdater.com, and then a start.windowsliveupdater.com, and just some random, looks like hex encoded strings.windowsliveupdater.com and end. So I thought that was kind of strange. And in this particular packet, this looks like an odd, or excuse me, this looks like an odd text query. And it took me a little bit to kind of figure this out, but if we go ahead and follow the UDP stream on this packet, we see that what looks like some more base64 encoded stuff. And so I'm going to go back over to our script, and let me just CD or open up a new terminal screen, and we'll vim script. And if we scroll down a bit, in this encrypt string function, we see that we are doing a bit conversion to string of some data, and we're replacing the dash with nothing. And the interesting thing that I noticed, and I'm not going to bore you to death with the entire process, is that each one of these base64 encoded strings is preceded by a dash. So it's essentially replacing that dash with nothing, and then it's going to do its decryption on these bytes. So what we can do in order to get a little bit further into this is we can copy each one of these. I kind of did this manually, so this is kind of the boring part, but I'm going to vim, we'll call this DNS, we'll call it txt underscore responses. I'm just going to paste each one of these in here separated by a new line. And this is just how I went about trying to solve this one. And full disclosure, I only solved the first half of this flag. I will give credit where credit's due for the second half. After the event, I found in the Discord there was some information given as to how some users found or solved the second half of the challenge. So this whole first part is what I did, what process I went through in order to solve this challenge. And I will give a shout out to the individual that I stole their solution for the second half. But there's no shame in my game. This is just how you learn. I learned a lot with this, and I thought it was a really cool challenge. So I wanted to showcase this because you might find this useful as well. So we'll copy this. I'm going to close that. And now this last entry here is going to be a little bit different, and I will show you why. So if we look at when you move your mouse over the data, it highlights the specific data chunks that are actually part of the same set of data, I guess. But so this one is one base64 encoded string. This one is another one. This is another one. But we get down to the very last one. It only selects the M3 to the end. So this AAT is actually not part of the string. And understanding a little bit about base64, the AT character is not something that you would see in base64. So we actually don't need that part. So I'm going to go in here and delete these two pieces. And we're just going to write and quit this. And now we can zoom out. And we can actually, before we close Wireshark, well, we'll close it for now, and then we'll come back to that. So now that we have these text responses, we can go ahead and vim our script1.ps1 again and take a look at how this is actually going about some of this. So the decrypt string, this is the part that actually ends up taking care of, this is the function that takes care of decrypting those base64 encoded objects. Because you can see here we have a system.convert from base64 string, the encrypted string with the input vector, or initialization vector, I think is what that means. And then we're going to do some more operations on that, create the decryptor, and then it's going to get the UTF-8 string from the unencrypted data. Not really great with PowerShell. I kind of can understand it and read it a little bit. This is well beyond me. I'm kind of a script kiddie when it comes to PowerShell stuff, but for the most part, as long as you understand that decrypt string decrypts the string, and there's an encrypted string that's in base64 like we just found, that this is going to be something we can use to kind of unpack that that stuff that we just saw a minute ago. And coming down a little bit further, we have a variable of encrypted string, and it has this output from the resolve DNS name windowsliveupdater.com, and it's selecting some stuff, and then our back to plain text variable is going to run the decrypt string with our key, which we have here, and our encrypted string, which is what we're going to be passing in a few minutes. And so before we go any further, just one more time, I'm going to go in and open up Wireshark on the PCAP, and we're going to filter out for DNS once again. And sorry if I'm losing you. I'm trying to recall my thought process on this. This was a little bit, I spent probably 2 hours on this one to get as far as I did. But we have our queries from our potentially compromised host to this Windows Live Updater IP, and then we have our responses. I'm actually going to create a filter for the responses. So we're going to right click on the source IP, go to prepare as filter, selected, and then right click on the destination IP, prepare as filter, and selected, because we want just this. And if we hit enter, we can see that we get our responses that we want. And it's just, instead of getting the DNS query and then the DNS response, we're just getting the DNS response. And you can see that we have our text query, which has our base64 encoded stuff. Then we have a start multiple hex string.windowsliveupdater.com end, and then start more base or more hex stuff in. So this is all the stuff that we're actually interested in. So from this point, we can actually, now that we kind of identified what we are looking for, I wasn't sure exactly when I would need this stuff, but I wanted to go ahead and extract that data as well. So I'm going to kill Wireshark, and I'm going to run a tshark command that kind of filters out those specific things. So to do that, I'm just going to actually copy and paste this command that I've already prepared. And so we're running tshark on, I'm not ready for that one yet. We're running tshark on our, we're going to read in our capture.pcap, and we're going to select the fields that are equal to ip.source and DNS query name, and the capital Y is for a filter. So the filter for dns.flags.response equals 0, meaning there was a response, and the dns.query.name contains windowsliveupdater.com. And if we run that and we put in our sudo password, we see that we get the same data that we just saw in Wireshark a second ago. So we have our starts, we have our hex encoded strings, we have our ends, and that's good. That's what we want. So now we're going to actually pipe that into cut-d, and the delimiter we're going to separate on are the dots. That was the easiest way I could find to get that, because I don't know how many like spaces there are here or tabs, and with the T-Shark output like this, it's not easy to get the delimiter to get this thing here, but the dots do make it easy. So we're going to select field 4, and that's going to be 1, 2, 3, 4. So we're actually going to get this here, because this is all included in the 4th field. And I'm going to grep out, grep-v means ignore start or end. So I'm going to grep out the start and end. And so when we run this, we actually just get the hex encoded strings that we're looking for here, as you can see, as well as Windows Live Updater, because we had that those text queries. So what I'm going to do now is I'm just going to take that same stuff and I'm going to pipe that into a file called data, and then I'm going to vim data so we can clean this up a little bit. And we're going to do we're actually going to delete these first 2 lines, and then we're going to do a little bit of vim magic with some substitution of 15, and then I believe it was a tab. Yeah, it was a tab. And then we're going to say we're going to replace it with nothing, and we're going to do that globally. And then once we hit enter, we should see a line starting with CC1 C9, and it went to the bottom, GG back to the top, and we can see we got CC1 C9. So that's actually the data we want. So we're going to write and quit that. And if we go back to our first T-Shark command and we look at it again just to verify, we can see that our very first hex encoded.windowsliveupdater.com starts with CC1C9. So that verifies that we got the information that we're actually looking for. Okay, now, so this is where it gets a little bit interesting. So we have this text responses. So I'm going to look at that one more time. We have these text responses that are base 64 encoded, and if we look at the working directory we're in home Kali CTF HTBCA forensics automation. So since we don't have, I'm going to go back into script, since we don't have the ability to run this resolve name type text windowsliveupdater.com on this server, we're actually going to have to get our output another way. So we've got to make some modifications to this. So I'm going to comment this line out. Actually, yeah, I'll just comment this line out, and then I will create a new out variable, and this is going to be to get content, and then we're going to put in our file name, which is home Kali CTF HTB CA22 forensics automation and txt underscore responses. So we already have the data. We don't have to actually run this query. Initially, when I went through this challenge, I was not able to successfully run the query. And also in PowerShell core, since I'm on Linux, the resolve-DNS name is not available commandlet in PowerShell core. So that's something that we're not going to be able to use. I didn't feel like going to a Windows system and bouncing back and forth, so I'm just doing it this way. So we're going to hard code that variable in there, and then we're going to write this. And since we're not actually getting the string properties, since we commented this out, we've already got the line we need. We don't need to get the dot strings and the first item in the string, so we can actually get rid of this part too. So now what we can do is we can write host and back to plain text, because we're actually interested in the plain text of this to see where this goes a little bit further. And then I'm going to just comment out the rest of this stuff here and that way we don't have to worry about breaking anything else. So so essentially what we're doing, we're just allowing this script, since it's doing its own type of encryption, and it's not just straight up base 64, it's got all this other stuff going on. We're allowing this script to essentially decode itself and give us back the plain text. So if we write and quit this, I don't think I have any other windows open. No, I do. Okay. All right. So if we write and quit this, then we can go ahead and run PowerShell on script.ps1, and it should decode all of this stuff here. And so let's kick this off, and it works. So we see that what's happening is these strings up here are actually executing Windows commands over DNS, which I thought was fantastic. When I made it this far, I was I was floored at this is a really awesome challenge. So we see we're getting the host name of the system, we're seeing what user we are, getting the IP configuration, checking for any antivirus, and then we're setting a user. We're creating a user called default user, and the password is this blob of text here, and adding it to the local group administrators and remote desktop users. So that's pretty cool. And then it's also allowing a firewall rule to allow port 3389, which most of you may know this is RDP on this device. So that's pretty scary stuff. But once again, going back to our base 64 knowledge, this looks like a base 64 encoded string. So if we take this and we echo this into base 64-D, we can see that it actually is a base 64 encoded string, and we get the first part of our flag. So that was awesome. I thought that was really cool. So then we got to figure out how to get part 2. So now this is the part where I got stuck. I'm just going to go ahead and vim a file called flag and paste this in so we can save our progress here. And we got the first part of our flag. So this is the part where I kind of got stuck. I'll show you what I did and how far I got with it, but I didn't actually get anywhere. I felt like I was on the right track, and I'll point out the solution here in a little bit. So what I did is I'm going to create a file called, I just called it I don't know.py. So I'm just going to call idk.py, and we're going to set our shebang line user bin env python 3, and then I created a list object called lines, and it's just going to be an empty list. And so we have this data file, and we remember that our data file is cat data. Our data file has these hex encoded strings. So I thought, okay, well, I can just go ahead and I can create I can loop through and hex decode these strings and maybe get a little bit more. So in order to do that, we have with open, we're going to use a context manager to open this data file that's in our current directory, so we don't need to specify a full path. We're going to open it in read mode, if I could type, and as F, so we create in our file handle, and then we're going to say lines equals, and actually this should be line list. You don't want to clobber your variable names, so that's going to be lines list. So lines equals f dot read lines, and then we're going to do a list comprehension of lines underscore list dot append l dot strip, because we want to strip out the new line character, and it's going to be for l in lines. I believe that was correct. And then afterwards, we're going to loop through for I in lines list, and we're going to print bytes dot from hex on I, because we know that our data is going to be hex. So once we save this, essentially, one more time, we've got an empty lines list that we're going to append. We're going to open up our data file. We're going to take in all the lines from that data file and store it in a variable called lines. And then for L in lines, we're going to append L, which is the item we're iterating over, dot strip, take off the new line character. So we essentially get the data file that we get in a list format that we can iterate with over Python. And then for every item in the lines list, we're going to print the returned bytes from hex value on that list. I hope that makes sense. It's been a long week, so you have to bear with me. I do apologize if it doesn't make any sense, but so Python 3, and then we're going to do on idk.py, and we get our stuff. So let's just redirect that into another file called stuff, and then we're going to vim stuff, and then I want to do some more substitution, so a little bit more vim syntactic sugar. So B apostrophe, I can't think, single quote. We're going to change that to nothing, and then we're going to substitute the single apostrophe at the end of each line with nothing, and then we're going to substitute the \x. We have to escape the backslash, so we have to type 2 backslashes, and we're going to set that to nothing as well. And then once we do that, we get some more gobbledygook. But the problem with this is a lot of this stuff is not base 64 proper character sets, so we can't actually decode this from base 64 because these are not, like, there's a space and semicolon. These are not actual base 64 characters. So this is kind of where I got hung up, and this is where I've got to jump in and give a shout out to Trickster for this little snippet of code that I saw in the discard after the challenge was over, after the CTF was over. So I didn't get any points for this, but I did want to get through this challenge. So I'm going to go ahead and demonstrate the solution that I found in the Discord chat, and this is where it got really cool. So we can just quit this. That file doesn't matter anymore. So we have our data file and we have our script. So I'm going to go back in and vim. Let me make sure I don't have another window open. I don't think I do. Okay, that's the only window I've got. So let's vim our script, and we're going to go down a bit, and based on that snippet of code, we're going to go ahead and input another function. So I'm just going to copy and paste the function. Again, I'm not taking credit for this, giving credit where credit's due. This is where I'm going to be a script kiddie. And actually, let me undo that and set paste so it formats properly, and then we'll go ahead and paste this in once again. So what this guy ended up doing is he created a decrypt DNS exfil function that takes in the key, which we know we have, and then our data, which is going to end up being the file from our data file, and then he's splitting the data and replacing 2 characters with 0x and then whatever 2 characters end up following in a space. So we can actually kind of walk through this real quick because I like to demonstrate how this is going to work. So I'm just going to open up a PowerShell real quick, and if I set a variable data equal to and we'll say 4D 673E, and then we say this next line here, this byte split data replace, we'll go ahead and just set a variable called hex just to kind of speed things along. I don't want this to get too long. So we're going to do our byte dash split, and then data. So we're going to pass in the data object, replace dot dot, and then 0x $ampersand space apostrophe. So we have our hex. Get an error here, so I did something wrong. Let me capitalize this. Maybe that will work. No. Oh, this needs to be a 0, not O. Okay, so now if we print hex, we can see that it actually splits it out. And this here actually, let me do this line real quick too, just to demonstrate how it goes in order. So this happens first, where you can see our data that our string was 4D673E. It gets split and then it gets put into what looks like a hex format. And then from there, we're actually splitting the bytes. We're going to split that as a byte object, and it's going to render this in as what's going to be represented as hex. I don't know that 103 is actually a hex thing, but that's what this ends up doing, and that kind of works. So, and then if we convert to base 64 string our hex variable, we can see that we get a base 64 encoded string. So that's how this stuff actually ends up getting turned into base 64, as it goes through this, this strange encryption algorithm that was created, and then it does its magic, and then you get your stuff. So I hope that made sense. I probably butchered that explanation. You can flame me in the comments if you want to, but that's the way I understand it. So now we can actually go ahead and we can call our decrypt DNS exfil. Function on with our key argument, and we need a data argument, which we know is going to be a file, and we save that in a file called data. So that's going to be in home Kali CTF HTB CA22 forensics automation and data, and we need to wrap that in parentheses. Oh boy. If I remember that I'm in Vim and need to use the proper keys to do that. And we want to get the content. So we have to do get content on that file. So now we can actually do what we need to do. And just to make sure, I don't think we actually will need this part here, so I'm going to go to the bottom and just insert comments, because I don't think we're actually going to need that. So I think we got what we need here. Actually, let's do one more thing. Let's add one more piece to this function. I'm going to set another variable and call it part2, and we're going to actually do that here. Part2 equals, and then at the end of this function, we're going to write host part2. That way we can see what our data actually is. I think that's it. I don't want to do a macro. Okay. So now this time, if we run PowerShell on our script 1, we should be able to get the rest of our data, hopefully. And we don't. So I messed something up there. All right, so I think I know what my problem is. I think if I go back into script.ps1, I don't think I actually need to do this variable piece here. Oh, no, wrong. I do need that. I don't think I need to actually set this variable, and I don't think I need this line here. So now if we try and run it again, pwsh script 1, and still nothing. So I'm missing something here. So what am I missing? I feel like that should be it. Oh, I commented out the key. Okay. So I'm actually, all right, so let me just uncomment these lines here. I might need that. I definitely need the key. And I might need these things. Let's try this and see. It's like I said, it's been a long week, and I'm actually going to paste this at the very bottom. So let's go to the bottom, insert, and I can actually just do a P for paste. All right, so let's try it now and see if this works. No, I don't want a Vim. No. So we're missing a closing bracket. Uncomment this. Oh, finally. All right, there we go. Okay, so now we actually get what we're looking for here. So this is actually returning the Windows IP configuration for the device. It does have some PAN antivirus 4.0, and then we see the wonderful part 2 of our flag. So what was happening is with our Wireshark capture, the initial text queries that we had, let me just open it up right quick. The initial text queries that we had were to get the data of host name, who am I, IP config, all that stuff. And then this is the answers to those queries. So basically, like, this hex encoded stuff is getting decoded to give us our the responses to the questions we were looking for. So we had to not only get be able to query the data that was being asked of the compromised system, but we had to decode the data in the responses to be able to get the second part of the flag. So now if we take this part of our flag, copy it, and we vim flag, we have the entire flag here. You can automate, but you can't hide. So once again, that was just a super awesome challenge. I probably spent more time on that one than I did on any others. I also have a video on the golden persistence challenge, which I will be posting up here as well. But that's it. Just that was super awesome. So I really want to thank HackTheBox for such an awesome CTF. There were a lot of challenges that I didn't even get to touch because I didn't have the time, and I got to be a little bit of a script kiddie and learn something at the same time. So I hope you learned something from this. I hope you enjoyed the video. Please like and subscribe. Leave a comment if you have any comments. You know, I know I'm terrible at PowerShell, and this is just a humble reminder of that, but I certainly learned a lot along the way, and I hope you did too. So hope you enjoyed it. Thanks for watching.